Okay, so this is going to be the work through of the test 1 review for college algebra. I will try and give you lots of background information or helpful hints or formulas in order to help you. Remember, you do have the answer key available to you on Blackboard as well as a blank copy. But I'm going to work through all the problems and try and give you guys a good, almost lecture style video in order to watch for this handout. Remember, if it's on the practice test or this review, it's going to be on the actual test, and the layout of the actual test is exactly the same. So the order of the problems and everything like that flows exactly the same way. So number 1 says, for the following linear equation, state whether the line has a positive, negative, 0, or undefined slope. So the key for these problems up here, 1A through E, is if you're able to, you need to write your equations into y equals mx plus b if they're not already written that way. The reason for that is because this m is our slope. The other thing to remember is that if you have a vertical line, then that looks like an x equals a number. That's a vertical line, and all vertical lines have undefined slopes. Like, they're just kind of notes that we've had from chapter 1, so hopefully none of this is brand new, but these are things you need to know before you take the test. If you have y equals a number and there's nothing else there, then that is a horizontal line, and horizontal lines always have 0 slopes. So these are kind of the things that we are looking at. These are the notes or the information we have to be comfortable with as we approach this problem. Now, A is set up exactly the way we want it to be. It's y equals mx plus b, so the m in this case is 4. That is a positive 4, so that means we have a positive slope. Notice I'm not writing what the slope is over on the line. I'm writing the words positive, negative, 0, or undefined. So for B, we have x equals a negative 2. This will be a vertical line at that x equals negative 2. And when we have a vertical line, then our slope is undefined. Sometimes doing a little graph like that can help you to see whether or not it's an undefined slope or a 0 slope. C is not written in the correct format. It is written in our point slope form, and so what we would have to do is we'd have to distribute this 1/4 inside of our parenthesis. So we'd have y minus 4 equals 1/4 x plus 2. Now here's the important thing, is that even if I add that 4 over, that doesn't affect my x term at all, and it's the coefficient of my x term that is my slope. So my slope in this case is the 1/4, which is a positive term. So you don't necessarily have to do the whole problem to get it into y equals mx plus b form, but you have to do a little bit. This next one is one I would be cautious of. Just make sure you actually distribute that in a little bit so that you can see that you do have a negative slope in this case. That'd be a negative 4x minus 4. So your slope is right there, which is a negative in this case. The last one says y equals a negative 3/2. You might be tempted to very quickly write down that it is a negative slope because it has a negative here, but this is a horizontal line at y equals negative 3/2. There is no rise in this case, and so because of that, we have a 0 slope. There's no change. So don't just think because it says a negative here that means we have a negative slope over here. That's not what that means. So that's how you do number 1. Number 2 says determine whether the following graphs are functions or not. You can literally write yes or no, is a function, not a function, whatever you would like that communicates that. When you are given a graph, in order to determine if it is or is not a function, it has to pass that vertical line test. If you can draw a vertical line at any point on the graph and it hits more than once, then it is not a function. So if we look at this first graph, while it is not a continuous graph, we do have this jump. It is a piecewise graph. Notice that we have a filled-in circle here and an open circle here. That means we include the point here, but we don't include the point up here. So even if I drew a vertical line through that, I would only actually be hitting the graph at that one point down here. So this is a function. This is a yes. If both of these had been filled in, then I could say no, it's not a function because it would hit the graph in 2 different points. So that's kind of what we're looking for. Over here, really, it's basically anywhere I draw a line, I'm going to hit in at least 2 points, if not 4 or more points like that. So this does not pass the vertical line test. It is not a function. And C, while we have sharp corners and all that kind of stuff, that's okay, but we still pass our vertical line test no matter where we draw that line. So yes, this is a function. So that's all we're doing on 2. 3, we're going to solve some equations. It says leave your answer in simplified fraction form as needed. So these might be proper fractions or they might be improper fractions. We just need to make sure that they are simplified if they do come up. So that's kind of the key. You do not want to give me a decimal representation on any of these problems. You will miss points for that. So for this first one, for A, we have 2n minus 3 equals 3n plus 5. I'm going to get rid of those parentheses by distributing first. So I'm going to distribute the 2 to the n, which will give me 2n. 2 to the negative 3 will give me a negative 6. Equals 3 to the n is 3n. 3 to 5, like 3 times 5 is 15. Now at this point you have a choice to make. It does not matter which side you move your variables to and which side you move your constants to. I usually choose to move all of my variables to where they're positive. So I would subtract the 2n over because I have more n's on the right hand side than I do on the left. That leaves me with a negative 6 equals 3n minus 2n will give me a 1n or just an n plus 15. Now I want to get n completely by itself. So I'm going to subtract the 15 over. Negative 21 equals n. There's nothing else for me to do. So over on this line, I'm going to write n equals a negative 21. And I am done. If you have more time at the end of your test, a good rule of thumb is to plug in your answer into the original equation wherever there's an n and check to make sure you get a true statement. I'm not going to do that here, but if you have time, that's always a safe thing to do to make sure that you didn't drop a negative somewhere. All right, for B, we have fractions involved. Fractions are our friends. So we have 3/5 y minus 2 equals 3 over 8. Now, there's a lot of different ways that we can do this problem. I can play with the fractions the entire time, or I can choose to get rid of them. I generally choose to get rid of my fractions because I don't want to play with fractions because they can be complicated. So if you were choosing to play with your fractions, you would add the 2 over. You'd have to get a common denominator to combine those, and then you would divide by 3/5. And that's what you would be doing. I'm going to choose to get rid of my fractions, and the way that we get rid of our fractions is to multiply everything, and I mean everything, by the LCD. So we're going to multiply by the LCD. Okay, so the LCD is where we look at the denominators, and we have a 5 and an 8. They don't share anything in common to get started with, like 5 is prime, 8, the factors are 2 and 4, so all I do is multiply 5 by 8, and that will give me my LCD. So my LCD is 40. So I'm going to multiply 3/5, the negative 2, and the 3/8 by 40. So I'm going to take 40 times 3/5 y minus 2 times 40. I wrote it inside the parenthesis. It doesn't matter if you put the 40 first or second. Both of these are correct. And then we have 40 times 3/8. And then I like to do a lot of my simplifying on the front end. And so what I mean by that is I know that 40 is 5 times 8. So there would be a 5 on top and a 5 on bottom. So those would cancel out. Meaning, instead of taking 40 times 3 and then dividing it by 5, I'm just taking 8 times 3, which is 24y. Minus 2 times 40 would be 2 times 4, which is 8 with a 0, equals, and I'm going to do the same thing over here. 40 is 8 times 5. The 8s will cancel, leaving me with 5 times 3, which is 15. So pretty much in one move, by multiplying by the LCD, I got rid of all of my fractions, and now I have 24y minus 80 equals 15. So I'm going to concentrate on getting my y by itself, and the first thing I'm going to do is add my 80 over to the other side. So I get 24y equals 95. To get y completely by itself, I'm going to divide both sides by 24. So that means y equals 95 over 24. Now, I would want to make sure that I don't have anything in common with my 95 and my 24 that I can cancel out. So they're not both even, so the 2's aren't going to work. 95 ends in 5, but 24 doesn't, so they're not both divisible by 5. 9 plus 5 is 14. 14 is not divisible by 3, so they don't share that. And then you could continue to go through a couple of the others to see if it is divisible by, let's say 7 or something like that. But 24 is not divisible by 7, so it doesn't really matter. 24 is only divisible by 2 and 3 whenever you really get down to it. If you get it down to the prime factorizations. And so since 95 is not divisible by 2 or 3, we are good to go on that. Again, you could always check by sticking that back into the original problem, or you could also work it the other way and make sure you get the same answer. That's another safe way to approach this. So let's flip over to the back of the front page. This is all one big problem. So you're given 2 points at the very start of this problem, and then you are asked a ton of different pieces of information. A lot of these different pieces of information deal with finding, using different formulas to find different things that they're asking for. So the first one says find the distance between these 2 points. Well, that means you need to know the distance formula in order to do that. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, anytime you use it, if you write it down, you're more likely to know it. And because I need an x1, y1, x2, y2, I'm going to choose to leave them in the order that they're already in. So x1, y1, x2, y2. It does not matter. You'll get the same answer, though, if you flip-flop those. And if you don't believe me, you can test it and you can see. All right. So x2 is a negative 3 minus x1, which is a 5 quantity squared, plus y2, which is 4, minus y1. Notice we have a minus minus. That'll make it a plus inside of there. So be careful and look out for those double signs when they happen. Negative 3 minus 5 is a negative 8 squared, and then 4 plus 2 is 6 squared. 8 squared is 64, 6 squared is 36. We get the square root of 100, which is 10. Remember, whenever we take the square root, if we do not get a positive whole number out, we don't want to do a decimal representation. So these should always give you a positive whole number, or it'll stay in simplified radical form. And remember, when we take the square root, we're only concerned with the positive or the principal square roots because we're talking about distance. And so we wouldn't discuss negative 10 miles. That sounds a little bit weird. Okay, the next one is our midpoint formula. Midpoint is where you add your x terms together and divide by 2. You add your y terms together and divide by 2. Notice that these are already in parentheses, and that's because if you're finding a midpoint, then you're going to have an ordered pair, and that it has to be how your answer comes out, is as an ordered pair. So x1 would be 5 plus x2, which is a negative 3 all over 2, comma, y1, which is a negative 2 plus 4 all over 2. So plus minus would mean that we're going to have a minus situation going on here. So it's 5 minus 3, which is 2 over 2. Negative 2 plus 4 would give me 2 over 2. 2 over 2 is 1, 1. So there's my midpoint. Now slope is rise over run. Slope y2 minus y1 over x2 minus x1. So notice by putting down these different formulas, I'm just plugging and chugging as we go through. So that'll be 4 minus my y1, but that's a minus minus, so that'll be a plus, all over x2, which is a minus 3, minus my x1, which is a 5. 4 plus 2 is 6. Negative 3 minus 5 is a negative 8. One rule, remember, is that we don't generally leave the negative in the denominator. We would pull it out to the side or bump it up to the top. That's just kind of the way we would do it. But then also we have common things here. We have a 6 and an 8. They're both even, which means a 2 would cancel out, leaving us with a negative 2, or excuse me. I really messed that up. If I divide both of those by 2, I get a negative 3/4. Sorry. When you try to write and talk at the same time, you're more likely to make some mistakes. Okie dokie. Part D says find the equation of a line that passes through these 2 points. If I'm asking you for the equation of a line, that means I need y equals mx plus b as my final output. However, I don't know what my b is, which is my y-intercept. All I know is slope, and then 2 of my points are at the very beginning of this problem. So I'm going to have to use my point-slope form first, then manipulate it over into this y equals mx plus b form. Now, it does not matter which point you choose. The general formula is y minus y1 equals m times x minus x1, and because it's using x1, y1, I'm still going to choose to use the first ordered pair given in this problem, which is 5, negative 2. The only reason why I'm saying that is just because it's listed first. It's already labeled as x1, y1 up at the top, so that's what I'm going to do. But once again, if you chose to use negative 3, 4, you would actually get the exact same answer out at the very end. So it's your preference on this. But y minus y1, well, y1 is a negative 2, so that would make it a positive 2, equals a negative 3/4 times x minus 5. Now, don't just stop there. Remember, we want to get it to y equals mx plus b form, so I'm going to have to distribute that negative 3/4. So I have y plus 2 equals a negative 3/4 x, and then I have a negative 3/4 times a negative 5. Negative becomes a positive, and then 3 times 5 is 15, all over 4. Last thing I have to do is subtract the 2 over. So I subtract 2. If you need to come over and do a little bit of side work, if you had negative 2 over 1 and I have a common denominator of 4, I'd multiply the top and the bottom by 4, giving me a negative 8/4. That's actually what I'm going to do over here. I'm going to take 15/4 minus 8/4, giving me a final answer of y equals a negative 3/4 x plus 7/4, because 15 minus 8 would give me a positive 7. On these problems where I don't give you like an answer line, if you would box or circle or highlight your answers, that would greatly be appreciated. You don't have to, though. I will go search for them. Now, we learned that the easiest way generally to graph a line is to plot the y-intercept and then use the slope to plot a second point. And you guys are probably looking at this problem thinking, well, that's really gross because that's, what is it, 1 3/4, and so you want me to plot that and then go up or down 3 and to the right 4. No, don't make this harder than it needs to be. Think for a second about what you need to graph a line. In order to graph a line, you need 2 points. Well, look at what happened at the very beginning of this problem. You are given 2 points. So if you get a really gross y-intercept like that, or a really big slope or something that's not going to fit on your graph, you can literally just plot the 2 points that are given and connect them, and you're done. So I'm going to plot the point 5, negative 2. So I'm going to go 1, 2, 3, 4, 5, down 2, plot that point. That was point 1. My second point was negative 3, 4, so that'll go 1, 2, 3, and then positive 4, 1, 2, 3, 4. Plot that. I will not grade you on how straight your line is. I happen to have another piece of paper here, though, so I can connect them. If you have a ruler that you want to bring, that is fine, but you will not be graded on how straight your line is. You will be graded, though, on whether or not you put arrows at the end of your line. Because if you do not put arrows at the end of your line, then you actually haven't drawn a line, you've drawn a line segment. Again, that sounds really nitpicky, but they're completely different things in math, and so we have to make sure that what we are using is actually correct. Okay, This last bit, students usually want to struggle with, but you don't need to. State the equation of a line parallel to this line. So what you have to know here is, what does it mean to be parallel to another line? Parallel lines mean they have the same slope. So we just found what our slope was up here a minute ago, which was -3/4, and here was the equation of the line that we just graphed. Y equals -3/4 x plus 7/4. So a line parallel to that would be y equals -3/4 x. That would run through the origin. Or you can put plus or minus literally any number that you want except 7/4. Okay? Don't make this overly complicated. This is a completely correct answer. Now you do have to give it as an equation, which means you have to have y equals. So don't try and skip too much. Now, perpendicular lines, their slope are negative reciprocals. Negative reciprocal slopes mean you take the slope, change the sign, and then flip it. So if -3/4 x, if this is the equation of a parallel line, you can write y equals, since this one's negative, the perpendicular one would be positive, and then we flip it. It'd be 4/3 x. And again, you can put plus or minus any number that you want out there. It doesn't matter. Or you can leave it just as I have, and then what I'm saying is that I went through the origin. That is totally fine. But don't make those more complicated. The big thing here is you're showing me that you understand what it means to have lines that are parallel. You know that those have the same slope. Or you're telling me you understand what perpendicular lines are, where they have negative reciprocal slopes. So that's what we're doing on that problem. All right, flip over to number 5. We're solving inequalities. Write the answer in interval notation and then graph on the number line that's provided. So these are multi-step problems again. The nice thing about inequalities is we solve them the same way we solve equations. The big thing is if you multiply or divide by a negative across your inequality symbol, then we flip our inequality symbol. I'll point that out if it happens while we work through these, okay? So the first one, when I look at this, I notice that I have 3x on the left, but I have 6x on the right. Since I try to keep my variables positive to avoid those negative situations, I'm going to subtract the 3x over. That'll leave me with a -1 is greater than 6 minus 3 is 3 plus 5. To get x more by itself, I'm going to subtract 5 from both sides. -1 minus 5 is -6 is greater than 3x. To get x by itself, I divide by 3, and I get -2 is greater than x. Notice I didn't change my sign, and that's because I didn't divide by a negative number. Yes, I got a negative solution, but I didn't do any dividing by that, so this is fine. Now, generally, it sounds weird to me to say -2 is greater than x, but if you read it from right to left, it says x is less than -2. So I'm going to kind of write that over here, because that's going to help me write my interval a little bit better. If x is less than -2, that means the biggest it's going to get to is the -2. This is its upper limit. But because we are strictly less than, I use a parenthesis at my upper limit. And then I go down until I hit -infinity, positive infinity, always use just the parenthesis. So that is my interval notation, which it says give it an interval notation. Now I have to graph it on my number line. 0, 1, 2, 3, 4, -1, -2, -3, -4. Make sure you label them. Do not just draw one line on here. Like, give me a little bit of information. And then remember, you do have two options on how you're able to graph these. You can use the circles, or you can use parentheses and brackets. So what we're looking for is we're looking at our limit. If x is less than -2, that's my upper limit. So I'm going to have an open circle if I'm using my circles at -2. If I am less than, notice which way this arrow points. It points to the left, less than. So then I make a big arrow like this, and I shade in over here. If you like the parentheses and the brackets method, then you would do a parenthesis at -2 facing to the left. Again, you would have your arrow and it would be shaded in. Either one of those is correct. I show both of them here. You just pick one. You don't have to do both. Okay, for B, we have a complex inequality, meaning we have 3 different parts. I like to keep them all together. If it's written like this, then I just do the same thing to all 3 sides instead of to both sides of my inequality, and I like how that works. So the first thing I'm going to do, because I'm trying to get x by itself here in the middle, is I'm going to subtract 6 from that middle section. But if I subtract 6 from the middle, that means I subtract it from the left and I subtract it from the right. -4 minus 6 is -10, less than or equal to -2x, less than, we have 4 minus 6 is a -2. In order to get x completely by itself, I would need to divide that middle term by a -2, and this is where we would have an issue and we'd want to be careful. I am dividing by a negative. When I divide by a negative, that means my signs are going to flip. And so I circle them to remind myself that when I go to write my next line, I'm going to flip those around. I have -10 divided by -2, negative gives me a +5 output, and then instead of less than or equal to, I'm going to have greater than or equal to. -2 divided by -2 just gives me x, and then instead of less than, I have greater than. -2 divided by -2 will give me a +1. So I have 5 is greater than or equal to x, which is greater than 1. Remember, I need to have my lower limit on the left, but if 5 is greater than x, which is greater than 1, then this is actually my upper limit. So just like over here where I wrote it the other direction, I'm going to write this one the other direction, where I have 1 is less than x, less than or equal to 5. The reason why I rewrote it is because now my lower limit's on the left. Now it is set up for my interval notation, where I would have a 1 as my lower limit. Since it's strictly less than, I would have a parenthesis, comma, I go until I hit my upper limit, which is 5. That is less than or equal to, so I would use a bracket on that side. And that is my interval notation. So on my number line, I have 0, 1, 2, 3, 4, 5, 6. And again, I'll show you both with the circles and with the brackets. If you're doing the circles, notice that we have strictly less than at +1, and we have a less than or equal to at +5, which means it would be a filled in circle because we do include that boundary point, that end point. And then everything that's in between is what gets shaded. If you're using the parentheses and the brackets, if you already have your interval notation written out, that's all you're going to do. You're going to put a parenthesis at 1, you're going to put a bracket at 5, and you shade everything in between. So remember, you don't have to do both of those methods, just one of those methods. All right, let's talk about circles. Got a little bit here with a circle. It says, given the equation of x plus 1 squared plus y minus 1 squared equals 9, we need to give the center of the circle and its radius, and then we have to graph the circle. So if we don't know the equation of a circle, though, then it gets a little bit difficult. So the equation of a circle is x minus, h squared plus y minus k squared equals r squared. Where the center of the circle is our h, k, the radius is our r. So really, we don't do any math outside of, we have to know what the general equation looks like, and we have to recognize that the general formula has minuses. So if I'm given something with a plus, the only way to get a plus in there would be to have like x minus a -1. That means my h value is a -1. So you have to be careful. My h in this case would be -1, and then since it says y minus 1, that means my k is a positive value, so it's a +1. And then my radius, I would have to take the square root of whatever this number is over here. So the square root of 9 is 3. Again, we only consider the positive root, and that's again because we're doing something with distance. So once you have the center and your radius, you're going to plot your center, which is -1, +1, which is up here. And then from there, you're going to plot the other points using your radius. You're going to go up, down, left, and right. So if I go up 3, I go 1, 2, 3, plot a point, go to the right 3, go 1, 2, 3, go down 3, 1, 2, 3, and go left 3, go 1, 2, 3. And remember, as long as you have these points in your center and you try to make a circle, if it looks more like a football or a diamond, that's okay, as long as you try. If you make straight lines between these and it really looks like a very strict diamond, you're going to lose some points. So try and make it circular than that. I mean, see, mine's still going to have a little bit of a point, and that's okay. Oh gosh, this one's going to be a real bad circle. There we go. So see, it's not a great circle, but I have my points marked, and I have my radius correct, so it's okay if it's not perfect. You will not be graded on the circliness of your circle, but you do need to actually try to make it into a circle and not into a diamond. All right, flip over. We've got a word problem. Actually, 2 of them. 2 word problems. Professor Sprout's herbology class plants a rectangular garden of magic herbs with a perimeter of 39 meters. The length is twice the width. Find the dimensions of the garden. So I'm going to draw a picture of Professor Sprout's garden where we have the length and we have the width. And it tells us the perimeter of this garden is 39 meters. Now, remember that perimeter means we go around the outside. Area would be like the amount we'd have to mow. Perimeter is the amount of fencing. So it says the length is, remember that keyword is tells us that we put an equal sign there, twice the width. So the length is twice the width. So I'm just kind of making lots of notes. And we also know the general formula for perimeter is 2 times the length plus 2 times the width. So now I'm going to kind of substitute in the information I know. I know the perimeter is 39 meters. They told me that. And instead of writing L, I'm going to write 2W in for my length because I need to have it all to be one variable in order to solve it. So instead of 2 times the length, I have 2 times 2W plus 2W. So 39 equals 2 times 2W is 4W plus 2W. 39 equals 6W, divide by 6, and we get 13 halves equals W, because that's the simplified form. These would each have a 3 that would cancel out, and we get 13 halves. Now, I understand that that's not generally how we would write the width of a yard per se, so you can write 13 halves meters, or you can write 6.5 meters. Either one of those is correct. I will accept either one. I didn't state in the problem itself how to give me your answer. But after that, I need to find out what my length is because that's my width. So be careful you plug them in the right spots. But it says width is. Length is 2 times my width, so length is 2 times 13 halves. Notice I'd have a 2 on top and a 2 on bottom, meaning my length is just 13. So I'd have 13 meters for my length. All right, let's do our investment problem. Draco invested a total of $5,000 into Gringotts Bank. He invested part of that at a 3% simple interest and part of it at a 4% simple interest. At the end of 1 year, the investment has earned $176 in interest. So how much did he invest at both rates? This is our systems of equations problem and our interest problem. So remember, interest equals the principal times the rate times the time. And almost always we get to kind of ignore the time because luckily we only are considering the interest within a single year. And so that means you're multiplying by 1, which means you can kind of ignore it. I like to kind of make notes of what it is that I'm doing. And just kind of to understand what all I've been given because I've been given a lot of information. So I know that Draco invested $5,000 into two different accounts. So I'm going to make two different accounts. One of them was a 3% account. One of them was a 4% account. He did that for 1 year for both of them. And here's the issue. We don't know how much he invested into these different accounts. So we have an X and a Y. He invested X amount of dollars at the 3% and Y amount of dollars at the 4%. But at the end of this 1 year, from both of these accounts combined, he made $176 in interest. So in words, what that means is that I would have the interest at 3% plus the interest at 4% equals $176, which is my total interest. Well, what is the interest at my 3%? Interest is the principal times the rate times the time. So principal times rate times time. Principal on the 3%, we called it X. The rate is the percentage, which we convert over to a decimal, which is 0.03. And then the time is 1 year. So I'm going to leave that off. For my 4%, my principal was Y. And my percentage was 0.04, and that equals 176. So that's 0.03x plus 0.04y equals 176. That's one of our equations that we're going to use. The other equation we're going to use stems from the total amount of money invested. Because I just said that I'm investing X amount of dollars here, Y amount of dollars here, and then grand total, we know that Draco invested $5,000. So our other equation for our system is X plus Y equals $5,000. With these two different equations now, I can do substitution and I can figure out how much Draco invested at both of these accounts. The key to do that is we're going to solve for either the X or the Y in here and then substitute it in over here. It doesn't matter which one you solve for. I'm going to solve for the X by subtracting the Y, giving me X equals $5,000 minus Y. And what I'm going to do then is anywhere in that other equation there's an X, I'm going to plug in 5,000 minus Y. That'll give me 0.03 times my X, but X is 5,000 minus Y plus 0.04Y equals 176. The whole reason we do this is now I have one equation and only one variable. I have Y's. So I'm going to distribute that 0.03. 0.03 times 5,000 will give me 150. 0.03 times the negative Y will give me a negative 0.03Y plus 0.04Y equals 176. I'm going to combine these Y's because they're a like term. Negative 0.03 plus 0.04 will give me a positive 0.01y equals 176. Subtract the 150 from both sides. 0.01y equals, what is that, $26? Can you still see this? Yes, you can. Divide both sides by 0.01. And I find that y equals $2,600. Now, I just did all of that math, and I found something, but was that the amount at 4% or 3%? And that's one of the reasons why I like to make notes before I get started. Because I just found that y is 2,600, and if I look at my information over here, I have y over here with my notes on the 4%. So Draco invested $2,600 at 4%. And so I can fill it in and put it on the right line. And if I know that Draco invested $2,600 at Y, then I can substitute that back in and figure out how much he invested at 3%. Because the amount he invested at 3% is going to be $5,000 minus the amount he invested at the 4%, which is the $2,600 that we just found. So X is going to be $2,400, and X was the amount that was invested at 3%. So you want to be careful where you put them because you want to make sure you put them in the right spot. So taking some notes or color coding or labeling of some kind is going to be helpful to keep your stuff straight. All right. These are plug and chug style problems. Given that g of x is 3x squared minus 2x plus 1, find g of 3, g of negative 2, and g of x minus 1. You are not being asked to solve anything here. All we are asked to do is find what happens when we plug in these different values. If I put 3 into the g machine, what do I get out? And so what we do is we substitute that. Because notice it says g of x equals this. So g of 3 means anywhere there's an x, I'm going to put a 3. So that would be 3, because there's 3x squared times 3 squared, minus 2 times 3 plus 1. All I did was I wrote my g of x function, but anywhere there was an x, I put a 3. And now I'm going to start simplifying. That'd be 3 times 9, because 3 squared is 9. Negative 2 times 3 is negative 6. Plus 1. 3 times 9 is 27. Negative 6 plus 1 is a minus 5. So I have 27 minus 5, which gives me 22. Done. On the actual test, I feel like maybe I gave you answer lines, but maybe I didn't. So now we're going to do that exact same process, but now x is negative 2. So we're going to have 3 times negative 2 squared minus 2 times negative 2 plus 1. Negative 2 times negative 2 is a positive 4. Same thing here in the middle. And then we have plus 1. So 3 times 4 is 12. 4 plus 1 is 5. 12 plus 5 equals 17. For C, we have g of x minus 1. So anywhere there's an x, I'm going to put an x minus 1. So I'd have 3 times x minus 1 squared minus 2 times x minus 1 plus 1. Now, here's where you might be tempted to do some magic math with this x minus 1 squared and say that you will have x squared plus 1. Don't do that because that is magic math. When you try to do that and shorten it like that, what happens is you forget your middle term. Because what this is saying is I'm going to have x minus 1 times x minus 1. That's a binomial times a binomial. And the way that we multiply binomials by binomials is we have to FOIL. So I'm going to write my x minus 1s side by side so that I go and FOIL. Now that doesn't mean I can't do anything on this first part. I can go ahead and distribute that negative 2 to get rid of that second set of parentheses. Negative 2 times x will give me a negative 2x. Negative 2 times a negative 1 will give me a positive 2. Then I have a positive 1 out there as well. So I'm going to ignore this 3 for a minute. I'm going to focus on just FOILing here. Okay? I'm going to skip some space so that I can do my FOIL. Right, 3 times, remember FOIL, we have our first, which is x times x, which is x squared. We have our outer, which is a negative x. We'd have our inner, which is also a negative x. So that would give me a negative 2x. And then our last would give me a negative 1 times negative 1, which is a positive 1. Then out here we still have a negative 2x, and then I had a 2 plus 1, which is 3. Now that I've done that, I can distribute this 3 into each term for my trinomial. That would give me a 3x squared minus 6x plus 3 minus 2x plus 3. Now I'm combining like terms. I have 3x squared. Notice I have a minus 6x, a minus 2x, giving me a minus 8x. And then I have a 3 plus 3, giving me a plus 6. I cannot combine any further. I was not asked to solve. I'm not setting this equal to 0 and factoring or anything else. This is all I'm doing. So don't be tempted to go further, because then you've just magic mathed it and messed up all of your beautiful real math. All right, number 10 says find the domain of the following functions. Write the domain in interval notation. Remember, the starting point for a function is the domain is negative infinity to positive infinity unless it's one of two situations. So of course, we're going to see this a little bit. One of the situations is if you have a radical, because the issue with radicals is we can't take the like the positive root, so like a square root of a negative number. And so this bit in here can't be negative. Anywhere that would be negative is a problem. Remember, we called them problem child or children or trouble spots. So if I have a negative under the radical, that x value is a trouble spot and I can't have it. And so I don't want that value to remain in my domain. And so what I need to do is I need to figure out, well, what problems then do I have? Well, I would need everything under here. If it can't be negative, I need everything under here to remain positive. And so I want this x plus 5 to be greater than or equal to 0. It can equal 0 because the square root of 0 is 0, and that's fine. That doesn't break our function. But I don't want this to be a negative. And so I have to keep it greater than or equal to 0. So I'm going to subtract the 5 from both sides, and I find that x is greater than or equal to negative 5. As long as that is true, then I don't have any values that are going to break my function. And so if I'm writing this as an interval notation, notice that x has to be greater than or equal to negative 5. Negative 5 is my lower limit. Since there's an equals to, I would have a bracket, negative 5 going all the way until positive infinity, and there is my interval notation. Anything less than negative 5 is going to break my function. If I plug in a negative 6 in here, I would have the square root of negative 1, which gives me an imaginary number, and we're not going to do that right now. So we don't want that. So that was one of the situations that could cause problems with our functions. The other issue is that if we had a variable in our denominator, then what could happen is we could get a 0 in our denominator, and we can't divide by 0, and so that's a problem. And so we don't want this can't equal 0. If this bottom denominator equals 0, then we have issues. So what x values then make it go to 0? So in order to figure that out, we have to set the denominator equal to 0. Because then we can figure out what x values send it to 0 and what x values then need to be excluded from our interval. So I'm going to try and factor first. Always try and factor first. The x squared tells me I'd have an x and an x. The fact that there is a negative in front of my c term tells me I will have a positive and a negative within my factored binomials. Then I need to look at factors of 8 that would subtract together to give me positive 2. Well, 4 and 2 give me 8, and if I have a positive 4 and a negative 2, then that would give me a positive 2 here for that center term. Remember, when you factored, if you want to check it, FOIL it back up and make sure you get to the top. There's a lot of times that people have these signs mixed, or they do some sort of cross method and they forget what it is they're actually looking for. So make sure you do refoil it and get back up to the same starting point. Now, by our zero factor principle, I can set each of these equal to 0 and solve for my x. Subtract the 4, and I get x equals negative 4. Add the 2, and I get x equals positive 2. So when x is negative 4 or when x is positive 2, both of those are going to break my function. Because if I plug those in, I'm going to get a 0 in my denominator. So I do not want to include these in my domain because they are problem children. And so what I want to do then is I want to think about the fact that I'm starting my domain from negative infinity to positive infinity, and then anytime I hit one of these points, I'm going to cut it out. That's why I use my unions to cut out those points. So I'm going to go from negative infinity until I hit my first problem child. Negative 4 is going to be the first one because it's less than 2. So then I'd hit negative 4. I'm going to cut it out though, and then I'm going to go for a negative 4 until I hit the next problem child, which is 2. Cut it out, and then I'm going to go from 2 to positive infinity. So if you have 2 problem childs or trouble spots, you're going to have 2 unions. If you have 1 trouble spot, you're going to have 1 union. If you just get an interval or a range like we did over here, then we just get a whole interval or a range that we get to cut out, which was everything less than -5. And that is all of the problems on the test 1 review.